Welcome to Danielle Smith's Fraser Forum. This program is part of a series of podcasts doing in-depth interviews on free enterprise and personal liberty. I'm your host, Danielle Smith, president of the Alberta Enterprise Group. Go to fraserforum.org where you can subscribe, comment on the program, and see links to the studies we discuss. You will also find archives of previous episodes. Our email address is danielle@fraserforum.org. We'd love to hear from you.
Models don't add new. They don't add new information. They just extract from existing information to create a possible explanation of reality. The real problem here is humans are inclined to grab onto models, and it's an evolutionary thing, which is it's better than nothing in theory, right? Humans actually, the way we think is by models. The problem is that it's not always a good way to think, right? It's not always, the models are not always correct, either inside your head. And if we then mathematize them and push them outward, we take our errors with us.
Danielle Smith, and this is another episode of Danielle Smith's Fraser Forum. I am delighted to be speaking today to Ken Green, who is a senior fellow with the Fraser Institute, many other institutes as well, but I've spoken with him many times in the past on environmental issues, and I'm particularly excited about your new book, Ken, on the issue of models, a plague of models, which I think is aptly named. So let's begin by talking a little about what brought you to that issue. When did you start seeing that the issue of modeling had become a problem in how we analyze public policy?
Actually, quite a ways back, and it was actually some relatively abstract topics that preceded, for example, climate change or even the air pollution fights. When I first started, I did my doctorate. I was studying air pollution control measures in Los Angeles, and one of the things that was common was you would read about plans to get people to take transit, and as opposed to driving their car, right? And I noticed that the predictions for how many people would use a transit line were wildly at odds with what actually happens or has ever happened in transit systems. And it was obvious to me that these are models. What they're doing is they're making a model of, we think if we build this, then we think the population here will grow, and then we think the demographics here will change, and then we think that if this happens, then this number of people will take our transit system if the price is right and if. So it's a nested series of what ifs, and that's what a model is. It's actually not, I have data and I cut my data down into pieces to understand it better. It's, I ask a series of questions and I come up with this scenario that may or may not be real. And I first started seeing then that was not a reasonable way to plan, and it was not a reasonable way to go to people and take their money. It was not a reasonable basis for saying, we're going to force you out of your car and force you into a transit system that we haven't built yet, based on our expectations of the future, our vision of the future, our model, as it were, of the future. That's when I started getting sensitized to it, and that was 1994. So
my goodness, well, let's talk a bit about that, because you're taking me back to my econometrics courses when I was at university. And my recollection of that whole experience was that you take a lot of data, you determine a lot of variables, and then based on what you've seen historically, you're able to project out into the future and get an idea of where you might be going on whatever it is that you're trying to test. So it seemed to me that the foundation of doing that forward modeling was based in some kind of empirical data based on what you saw in the past. So are you saying that they're completely divorced from each other now in a lot of modeling, or that the past isn't a particularly good indicator of the future?
Well, I'm gonna tick off my econometric modeling friends, but I would have to say it's all of the above. First of all, the past is not a good indicator of the present, but our understanding of what actually happened in the past is not good compared to an empirical understanding of what happened today, right? So the quality of the data in the past is worse the further back you look, and it's always incomplete. And so even if you're starting with data, which is historical data, you're getting an incomplete picture in the model you're building from the very beginning. I do happen to believe that unless you have a hard mechanistic understanding of a situation, extrapolating to the future is not rigorous. It's not an empirical activity. It's not science, essentially, or rational, or yeah, it's not an empirical thing, because if you have a mechanistic answer, like physics, for example, if I throw a baseball, I know where it's going to go, even if I'm not there to see it, and right, even if I die immediately, then it's still going to go there because I have a mechanistic physics understanding of what's going to happen. So yeah, I can predict the future that way. I can predict where Mars is going to be. I can predict where my spacecraft will join Mars and all that kind of stuff. But if you don't have a mechanistic understanding of what connects the data from the past to the data in the present, and then will connect it in the data in the future, right? You have nothing but a scenario here. You have essentially an imaginary scenario, not a connection to the empirical data of what happened in the past.
Well, let's talk a bit about the example that you gave, because I wonder why the data falls apart when you're trying to do present and future analysis. Because if I was constructing that model, I guess what I would look at is if you're trying to figure out whether a new line is going to have a sufficient amount of passengers, I would probably look at previous lines. I'd look at the demographic makeup of those lines. I'd look at destination points. I'd look at probably income levels, because you might get a sense of whether or not somebody had the money to keep on driving, or whether they were more likely to use transit. You'd probably look at the number of kids who would potentially take the transit line. So it seems like you can build a lot of information in that should be able to give you a pretty good prediction of whether the communities you're talking about are similar to ones where you've had success in the past. And so I think on the surface that maybe that's why people feel so confident about modeling. It's because on the surface you think, yeah, I can figure all this out. What falls apart? Why doesn't it work?
Well, it falls apart at a bunch of different levels, because first of all, the interpretation of what did and didn't work and happen in the past is subjective. So I would look at, for example, the history of transit in Japan and say, yes, it was a huge success because of overlapping bubbles of population density along one corridor that has existed for over 2,000 years, right? And so, yes, you could say, I know we have passengers along this route, right, who want to move back and forth. But I would not then take that model and say I could apply that to high-speed rail in California just because they both move at high speed, right? And so the problem is you have subjective interpretations of what worked and didn't work in the past, what is and isn't happening in the present, and what could and couldn't happen in the future. I like to basically say, boil it down to the number of uncertainties. How confident am I in what you have to say? Well, if there are no uncertainties, I'm highly confident. And if I'm going to get on a rocket and have it go off underneath me and go to the moon, I want to hear that you're not assuming things. Right? Especially assumptions. I want to hear, no, we're not really assuming anything. We have measured each of the things that might happen and go wrong, and we have a mechanism. The more uncertainties you add into it, the more assumptions. Well, we're assuming that the moon will be there. Well, I'm not getting on your rocket. So it's the same with those kind of plans. I like to say it's sort of my belief in your system is 1 over the number of assumptions you have. So if you have one assumption and there's what you're talking about one thing, I'll probably believe you. If you have 2, I'm less likely to believe you. If you have 4, I'm more likely not to believe you. And if you're out there with 6 and 7 assumptions, which is you don't have measured data, I'm not going to place faith in that estimate at all. And so the problem with models is you never get 1, which is the one assumption would be that we really are seeing the world as it is, that we live in an empirical world. Right, that's assumption number 1, that we live in a concrete world of matter and energy, and right, and it obeys the laws of physics. But with any of these other models, you're out there multiple layers of assumptions that, to me at least, take you a remove from reality. When in the book I'm writing, I've been reading a lot about models, right? And what models are, they use an odd term when discussing models. It's called abstraction, because a model actually, by intent, leaves data behind, right? It abstracts a small bit of information to let you then project what it's going to do or understand what it's going to do, rather than looking at the whole. The problem is the choice of things you abstract may or may not be meaningful. So one of the things I give an example of is in the book I'm looking at, one of the abstractions we have is that, for example, I'll give you an example. An average, what is an average, right?
Yeah.
You know, mean, median, mode, right?
Yeah, you add up a bunch of different numbers, divide by the total number of numbers, and that's the number in the middle.
But does that value necessarily exist? Right? If you have 1,000 widgets and you measure their width and you add them up and you divide by the number of widgets, is there any guarantee that there actually is one at that central value?
There may not be.
No, there may not be. In fact, there probably isn't, right? So an average by itself is actually a model. It's an abstraction of the data. One of my stats professors used to, at first, drove me a little crazy because he insisted on referring to these as measures of central tendency, that they're models of central tendency, essentially, in the data. So, but the thing that they're modeling isn't there. The average human, for example, would have, one ovary and one testicle, but those people don't really. They're not the average person. So that's the problem with the thing you always have to remember about models is they're an abstraction from reality. They're not reality.
Okay, so now you're taking me back to my statistics classes, because I remember the distribution curve, and I'm wondering then if modeling would be more accurate if it gave a number of different scenarios, that this would be an outlier case on one side versus the other, but this would be the range in which the outcome that you might expect, just based on normal statistical distribution. Does that improve the model if you end up with a variety of different outcomes for decision makers to consider?
I would say it does, in a world of sincere, rational decision makers. So I would generally say, yeah, what you're doing is you calculate it and you say, this is what has happened up till now. Let's take our data of the average age of death in 1800, and it has gone like this over time. And we're going to extrapolate it forward under 3 scenarios. One is a scenario where things continue exactly as they are. We're going to do a straight linear extrapolation. Another one is things get up to 10% better, things get 10% worse. And here's the range of possibilities we expect in 50 years from now. And you hand that to your politicians, right? The problem with that is the scariest one immediately becomes the only point estimate. Right? So the discussion is what's better, a point estimate or a range of estimates. In terms of accurately describing reality, the range is going to be better. But humans don't like ranges. So if you were to see an actual diagram of an atom, it actually looks like a things. But we don't draw them that way. We draw the little electrons and the little protons and neutrons and things like that, because people go for point. And so when you provide a range of estimates, it's the scariest one is almost always going to win.
We are going to talk about a couple of examples where that is the case, but you have me feeling a measure of anxiety now, because in my home province, in our 2 large cities, Calgary and Edmonton, there's some massive transit projects that are being proposed, and both of them are centered on modeling of what future ridership is going to be. So here's the nature. The problem I think that politicians have is that they have pressure from a political point of view to make decisions, especially now increasingly on the issue of public transit. And so they have to use some sort of data on making a decision on whether making an investment today is going to pay off once it's constructed, because the time horizon can be 10 years from approval until it's actually built out. It could be 20 years before you get the empirical data that you're talking about to know whether or not it's been a success. So what's a politician to do when they're getting pressure? Yes, you must build rapid transit or LRT or whatever it would happen to be. How is there a better way to approach that issue if you can't use or can't rely on models?
And that's a great question and a great example of why I am not a politician. But because I think the thing is, I would just ask a question, which is, right. And so how did your transit plans work out compared to COVID? Right? How did the past transit plans that are in place going right now, how did that work out with regard to with COVID happening? And do you not think that there will be other things that will disrupt your plans like COVID did? And so that's why, as you know, I'm a libertarian. I believe in the power of markets to manifest what's going to happen or what people's values are. And I've written about this for Fraser in the past, which is we're still making plans for point-to-point transit, despite knowing that people have been moving away from the use of point-to-point transit for years, if not decades. It's not what people want. And also, we now have ride-hailing apps and things like that, which are door-to-door rather than point-to-point to feeder to location, right? They all presume, and actually they not only presume it, but they fix it. They pin it in reality. So they create rigidity in the system, which is we assume people are going to live here and they're going to work here, and we're going to make the line go like this. Well, but we've seen that doesn't happen. People actually, a lot of times people decide, actually, no, I'm going to work over here in a lump, and I'm going to work over there in a lump, and we're not going to do the commute thing anymore. That happened in California. It happens in all the cities actually. Wouldn't have they expand and they have rings form, and people, instead of going in and out to the core, they work in parts of the ring of the population. So I mean, if I'm a politician, I would say, really, it's time to move beyond the view of transit as being fixed point-to-point infrastructure and figure out how we can actually increase things like Uber and ride-hailing to actually give more people more flexible commute options rather than less. There is a pressure to build these things to be a world-class city. But really, the history, I guess if I were a politician, I'd say we all love this idea and the dream, but look at the experience, look at history, look at the high-speed rail in California, look at the failings of Amtrak, right, which is the massive money pit that is Amtrak and mass transit. Look at what has happened to transit after COVID. I mean, half the transit systems are practically empty and have been for well over a year. And people are showing great reluctance to get back on them, even masked or masked and gowned and vaccinated and in a spacesuit, right? Nobody wants to get into the tube of germs. So I think they have to have the guts to say, this has been our model in the past, but really it's not the model of the future, which is...
Do you know why? Okay, as people are listening to this, it makes a lot of sense what you're saying, but there's sort of two aspects that come to my mind. One is that I think there's a sense that if you build it, they will come. That part of what you need to do is build the infrastructure well. It's easy to put it in place. So there's sort of an engineering issue there. And then based on what you see in other growing jurisdictions, once we grow to that level of population, then we will get to the same level of ridership. But you're telling me that we're looking at the wrong statistics. And so in some ways, I think what politicians will say, well, if you don't like my model of what projections of future ridership would be, what's your model of how many people are going to use ride sharing? Can you beat a model with a better model? Or how would you approach the issue from an empirical point of view to make the case to decision makers that what you're describing, which is interesting because as you're talking about it, is the lived experience of everyone. The lived experience is I've been in way more Ubers in the last year and a half than I have on public transit. So intuitively, it makes sense. But it's remarkable how locked in people are to saying, show me some future projections so that I know I'm going to make the right decision. How do you respond to a politician who's been trained in looking at models and has come to a different conclusion? How do you get them to look at the correct data to make the right decision?
Well, and that's a serious problem, is that we have instead of having, let's look at the data, we have the battle of the network models, right? Which is, I've got a model, you've got a model. Both models are full of assumptions. But again, it gets back to this point, which we've forgotten that those are not data. Those are not evidence. They are just speculation. They're essentially hearsay, right? So none of these things would you like brought against you if you're accused of a crime. You're not going to be happy if the prosecution says, well, in my model, Danielle, she could have done all of this. We think she could have done it. We think she might have been in the right place at the right time. Maybe she had the right motivations, and we want to slap her in the pokey because we think she did that, right? You don't want to live in that world where people can just conjure up a model of what they think you are going to do and jail you. Like it's like pre-crime, right? We're going to jail you because our model says you're going to go rogue in about 5 years, so can't have that. So,
and there are some dystopian futuristic movies based on that. Minority Report comes to mind.
I just watched a piece of it. Yeah.
But you know what I think part of it is, and I'm wondering if you can unbundle this a little bit, because I've been talking to a number of people in the last little while about how we can use a lot of data and machine learning and artificial intelligence to build models that will allow us to, you name it. There's a whole variety of things that you can do there. And so is it that our human brains are not able to process enough of this information, or not able to run various iterations? But once we get better programming and machine learning and AI helping us out, that will refine the models, and we just have to feed more data in, and ultimately we will get more accuracy. Is there anything that has led you to believe that could happen?
Not particularly. Partly because the more power you bring in and the more, quote, data you bring in, the more uncertainties come with them. And so your error terms tend to magnify over time. You get, instead of having a possible range, is this nut exactly the right size? We have an error range on that. Is the bolt it's gonna fit the right size? We have an error range on that. If you could do that for every nut and every bolt and say, okay, now we have them all, you still don't have anything new. Models don't add new. They don't add new information. They just extract from existing information to create a possible explanation of reality. But the real problem here is humans are inclined to grab onto models, and it's an evolutionary thing, which is it's better than nothing in theory, right? Humans actually, the way we think is by models. So we have a model in our head that gravity exists and things will fall off the desk whether we're there to see it or not, right? But that's a model. And so the modeling is how humans think. The problem is that it's not always a good way to think, right? It's not always, the models are not always correct, either inside your head. And if we then mathematize them and push them outward, we take our errors with us, right? So I wouldn't be confident that just a massive expansion of computing power is going to fix it. In fact, one of the things I argue in the book is that the easy availability of computing power is such that you can start playing games with numerical simulations of things where I'm going to run this model with my assumption ranges. I'm going to run it 1,000 times, and I'm going to look for the one. I'm going to see what it says, but really, I'm going to look for the one that meets my pre-existing belief. I'm just not going to tell you about the other 99 times I ran the model and it said that was wrong, right? And so I'm not really sure that models it's going to be somewhat heretical, but I don't believe we should be using models as decision-making tools.
Wow. Yes, somewhat heretical.
Nearly as much as we do. It's unavoidable.
Yes,
that we will use them, but I think we have come to over-rely on them, and I think that the dynamic created with public choice theory and with human motivations has led to an abusive cycle of misuse of models rather than reasonable use of models.
I think there's no question. And I thought it was important for us to revisit the way you framed that as well, with that a model is not empirical data. And that I think is important for people to understand, that just because a model has numbers in it, it doesn't necessarily mean that it is data based. And maybe you should talk about that. What is the attractiveness that we have, that as soon as we put math or numbers associated with a projection, somehow it just seems to give it more credibility? Why are we hardwired for that?
That's a great question. I'm not a psychologist or a psychiatrist or even a sociologist, or an anthropologist particularly. I am a biologist, so evolution is part of my thing. But I don't really know why we humans are fixated on numbers. It is something I return to often. It's something we can talk about as well, which is the reality is we know humans are fixated on numbers, especially magic numbers. And we see that especially in politics now all the time. So we have 0 carbon by 2050, right? Why not 2050 2.5? Why not 0.1 carbon by 2037.6? No, we have to have round numbers. So we're going to get a 15% reduction in vehicle ridership in 15 years by the year 2015, right? And as if these numbers are magic. And people do fixate on them. We know that because we see it all the time. People fall for the magic number. And it's one of the things that drives me crazy is the false accuracy you read in reports all the time, which is we're going to go for this 13% we need 13% reduction in this by then. Well, really, what's the probability that it's actually 2 round numbers like that you really need out of all the other possibilities you could go for? Do you really need that number of reduction of plastic waste by that year? Or really, would it be okay if you had a different number by a different year? And maybe there is no magic number by a magic year, right? Maybe you actually look at it each time and you go, are we seeing too much crap in the environment? Yeah, well, I guess we need to crack down on that, as opposed to saying, I see a world of 0 this by 2050. I think that's a fallacy. It's a fallacious way of thinking. It is, however, one that humans are prone to, and everybody's. You want to seize on round. I love round numbers. I mean, there's a video game I'm playing where one of the stages I get to be 5 stars. I just happen to love the idea of 5 stars. 5 points in the star, number 5, 5 stars, 1 hand's worth of things. It's just a great number. I love 5. But is that what I say? That's really where I should stop. That's the best number. No, but I like it. So humans are not terribly rational in many ways. And the magic number thing is one of my pet peeves, which is we do focus on, when you put a number on something, it gives it a reality it probably should not have.
That's amazing. Well, 5 happens to be my favorite number too. Now you've just blasted apart why it's irrational.
I have a theory. It's the highest multiplication table you can remember when you get over 50 without having to think at all.
Oh, I think you're totally right.
You just don't have to think about it at all. 6s, you start to have to think, but 5s.
You do. 12s are always the 12 timetables were always the difficult one for me. So where do you think that this modeling pressure came from? Because I guess we've always had the ability to model. I kind of think of it as being part of this modern era when computers came about and when we began to simplify the ability to do these kinds of projections. It seems maybe that's when it escalated, or maybe it was issue-based. I mean, you had mentioned climate change modeling, and it's remarkable to me that I'm seeing so much of that bad climate change modeling, and we can talk about that in a minute, just carry over to bad modeling in other areas as well. So is that initial modeling to blame, or where do you trace this modeling boom back to?
Well, I'd say modeling, as I said, is innate. So humans are risk averse by nature, right? We live in fear of bad things, and so we want to see them coming, and so we look for patterns. We're wired to look for patterns that indicate something is coming our way, and we always have been from the very first people who looked up at the stars or try to figure out what the seasons were doing. You had a model, which is, I see it's happening like this, so I'm going to assume it's going to happen like this again at X time. And so I think it is our way of knowing, in a sense. Modeling is part of our human way of knowing. I think what happened recently is that the access to easy computer time and easy graphic representations of data led to a massive explosion in the use of modeling, but also people's belief in it,
Hmm.
right? When it was really hard, so we forget, like you and I, we probably went to school at a roughly comparable time. We took statistics. I don't know about you, but I took chemistry lab when I was doing, we had to do error calculations with a pencil, right? And if you try to do complicated things and you have to do them by hand, there's a real limit to where you can go. And then representing them graphically was also laborious. So until around 1960s, 1970s, most people, you didn't see charts in which multiple colors could be used to sway your emotions, and motion could be captured in the chart for you to see, to grab your imagination. Go, yeah, I see that intuitively. Those things just didn't exist, right? And so when you got the computer power and things like Excel, where you could just say, here's my big scatter chart of data. Now let's plot 5 different kinds of lines through there. I think it's a linear function. Let's check the linear function box. Oh, look at that line. Wow, that looks scary, Bob. But maybe it's a power function and it really goes like this. We'll click that button. And once you started having that happen, where people could take data and just start mining the data to look for patterns, I think that's where the beginning of what I would consider sort of the plague of model is that we had this new ability to mine data as opposed to grind data. We used to have to really grind that. So everybody loves those pictures of people in front of the giant chalkboard of equations, right? Einstein, men trying to understand women. We have these giant boards. Well, when you actually had to do that to make something happen, it was super laborious, and you didn't you didn't take a lot of chances with what if things go wrong? Well, then the ship blows up. Okay. But if you could just like pile your data into a machine and just say, let's just slice and dice this till we find an interesting pattern, that looks good. And now let's extrapolate it with another key click, show me that in 2050. You just couldn't do that before 1970, unless you happen to have an entire room full of grad student slaves to do it for you. It just couldn't be done. So I think partly the computer revolution is what initiated this reliance on models in terms of the way most people live their lives, because before this, you just wouldn't have believed it.
Let me add one more thing then too. If 70 is the turning point, then that also is kind of the era where we all started gathering around the television set. And so this kind of modeling with data and projections lends itself to doing television shows around. And so you end up with a very powerful means of getting the message out. And then layer on top of that the social media phenomenon that blew up in the 2000s. Now you've got all kinds of memes and infographics that push more data out, which in some ways is making us, I think, more dependent on those kind of models and projections, because the more we see them, the more we become accustomed to them, the more we see them, the more we desire them, the more people are demanding, I need to see a model before I can make a decision. So we're in a bit of not a virtuous circle, whatever the opposite would be, a vicious cycle.
Well, humans are visual creatures as well, and I think that's part of the point, which is being able to make a representation visually that reaches your senses in a deep way. Again, came in with the 1970s. I followed the IPCC reports, the Intergovernmental Panel on Climate Change, and I followed them since their second assessment report way back in 1992, I think it was. But if you look at the depictions of data, then they had black and white charts. They were very, very esoteric and detailed and hard to understand. And over time, they evolved into these big, beautiful, multicolored, moving parts, very simple and compelling graphics. But are they telling you the same story as they would without all the pretty? And I think that's a problem the IPCC has. The example I give is that, for example, in the second assessment report, the estimates were that a warming of 2 degrees would be largely benign, and above 2 degrees, you'd have some negatives and some positives as you worked your way up 2 degrees centigrade. And in future, but in later reports, they started changing that to as depicting the future parts in red. So the more warming it is, the worse it's going to get. And so that started getting color coded in red. So eventually all the charts look like in time the world bursts into flames, because it goes from here we're in yellow, things are at the 2-degree range, we're still in yellow, we're okay. 2.5, now we're getting orangey, and now 3.0 we're in red world, and right, and so, and humans instinctively assign meaning to the color, but is it an accurate reflection of what's going to happen in that data? And so I think you're right. The audiovisual nature of the modeling, improvements in modeling, are compelling to people, and we love them. And yeah, I happen to love memes myself. I think they're it's one of the things that's made me reconsider whether or not Richard Dawkins was either a genius or a madman. But which I reconsider every time he opens his mouth anyway. But I think memes are really kind of a fascinating subject. I'd love to go back in time and do a thesis on that.
That'll be a future book. I know it. Well, let me ask
I've got a long list of those.
Well, I'd love to know then how we should be interpreting those IPCC models, because some of what you've said, I've read Ross McKittrick and I've interviewed him as well, and he talks about many of the things that you're talking about, because we do multiple different projections so that you can get the range. But you're right, all of the summary for the policymakers and all of the environmental messaging comes out focused on the most extreme scenario. I think he's unbundled quite a bit about all of the absurdities that you would have to have work into that model for it to actually be achieved. I think we have to, quadruple the amount of coal being used in the world, and every poor country would have to have the same living standards as America. So there's that would be unachievable in that time frame, and yet that's the one that keeps getting put out there as the most likely. That's the business as usual model, is I think the way it's described. I've often felt like what needs to happen is that we need to find some way of overlaying the empirical data as we develop it, and then use that as a bit of a check on, okay, that model isn't that accurate. And I don't know if that happens. And I don't even know if that's the appropriate way for us to try to bring the real world into the modeling world. But that would be one of the proposals I would suggest to you. The only problem is that the time scale is so far out that if we were just adding data a year at a time and we're modeling out to 2050, I don't know that you would be able to make the kind of conclusions that would be helpful to policymakers. Right. So now you've put me square in the middle of a conundrum that I'm trying to resolve, and I wonder how you overlay the empirical data so that you can get the real world injected into the discussion.
It's a great question. Actually, you use the term business as usual, which I can use to illustrate that similar point, which is in the beginning of the IPCC reports, you really had two things that were discussed, two scenarios that were discussed. There was business as usual, or what happens if we do X, right? Our plan. And business as usual was bad. It was going to be the bad case. But we went from just business as usual or our plan to business as usual or one of 5 different scenarios of the future based on our speculation about what the population will be like, how big it will be, where it will be living, how much energy it will be using, how long it will be living, and how many days of working life, healthy work life you'll have, right? And we make these scenarios, and we're now comparing all of these really abstract things as opposed to relatively defined things like, I've taken the past, here's my data, and we can have that whole discussion later, but we have remarkably little data about the climate. Even though it seems like there's a huge amount, the first temperature records really go back to around the 1850s, and they were taken with thermometers that were painted by hand, and they were not they were not used to determine global temperatures. They were to determine the temperature at the middle of your city, right? And so the data that we have on the global climate is really quite modest if you actually think about how much data there is that you'd want to have, but could never have. So I think that your point is to get back to your question, which is there a way we could do this on a ongoing basis, not a predictive basis? And I think, and this is one of the areas I am exploring in the book I'm working on, which is we can do that in microbiology, which I did study and I liked, and I probably should have stayed with micro because it's a really cool field. But Very genteel as well. It's nice. As biology goes, you get to work with little flasks of bugs and things like that. It's good. But one of the things they do in a microbiology lab, for example, in a drug lab, where they're testing the quality of drugs, is they use things called quality analysis and quality control charts or systems. So you sample, let's say you're making a medication. Every day you pull a sample and you run tests on that sample to determine is the drug within the characteristics or parameters you want it to be in, right? And you chart that. And if that starts to vary from the number you want, you have several thresholds at which you take action. So when you're one standard deviation from the mean of where you want to be, you have a trigger to re-inspect your process and find out why your variance is going off in this direction and it's bad. Or if things are getting better all of a sudden, if you're actually like outperforming what you were doing, you look at it and go, hey, this is really good. How can we capitalize on this to actually make our process even better? But you use this sort of daily variation from the mean of what you want, as opposed to looking forward and saying, how do I get to this distant vision of things? It's the same as I said before we were, I think, recording, which is a great chess player, Pandolfini, was going up against another player, and he was favored to lose because the other player was notorious for thinking many, many moves ahead. He could declare checkmate in 12 moves and 15 moves. And the chess media asked him, said, Pandolfini, how are you going to beat this? How many moves ahead do you think in chess? And Pandolfini said, well, only one, but it's the best one. Right? I only look for the next move, but I look for the best next move. And that's, in fact, what chess computers really do. They keep looking for the next best move. But it's a bit where we need to get back to that kind of wisdom, I think, of let's look at what's happening now, and let's get a better grip on what's happening now and establish trigger points for how we're going to react, rather than saying, I'm going to stop the world and never let this thing manifest. That's the thing, that's where we're at now, which is I'm going to prevent the manifestation of a bad thing, as opposed to we're gonna work with what we have as we go along.
It's interesting because I'll want to talk to you more about the climate change challenge, because there's so many moving parts to it and it's so complicated. But I think maybe part of the reason why we simplified what the solution should be is because we've been there before with the ozone debate. We made the direct line association that chlorofluorocarbons were causing the depletion of the ozone layer. Therefore, get rid of chlorofluorocarbons, find something else to use for a refrigerant, and lo and behold, free enterprise worked the way it was supposed to. We had a little creative destruction, some new product came about, and now no one talks about the ozone anymore. I think you can probably look at a few environmental issues like that, because we had markets to reduce sulfur dioxide emissions and take lead out of fuel. And it seems like since we were able to identify a problem, we were able to chart a path to zero, we were then able to move on. I think that same model is now applying to our discussion about greenhouse gas emissions. That's what I'm thinking. Maybe I'm just using a model here and a construct to help me try to understand why it is we find ourselves in the situation that we did. But do you think there's some accuracy in how I've described history? And do you think we made the right decisions on those issues that I raised?
Yeah, I mean, one wants to avoid what I call narcissistic navel gazing or iterative navel gazing, which is we can keep asking, are we seeing something clearly? And we can just like go around in circles. Because on the one hand, I'd say, yes, we have these examples of there was a defined pollutant, a defined mechanism, a defined market. We established a market and we solved the problem. So acid rain would be a case in point, right? You had a defined problem, you had a defined one jurisdiction, the problem was coming from one sector, coal emissions, essentially coal power emissions, and you could create a market under the one jurisdiction where you could exchange value to find the least cost way to reduce, and it all worked. But the thing is, we focus on that one, but we don't focus on the 10 that failed. So like the same thing was tried in California with oxides of nitrogen for ozone. right? Where they had one pollutant, one airshed, one industry, basically one mix of industries, and they set in a pricing system. But a couple of flukes happened in the summertime where the temperatures just shot wildly up, pollution levels skyrocketed. The power system couldn't come up with it, couldn't produce it, so they had to bring online backup power, diesel and other backup power, and the air pollution levels were shooting up. The pricing system then drove the price for NOx emissions, nitrogen dioxide emissions, so high that it was insane. No one could be in business and buy a contract to pay that much to emit nitrogen dioxide. So they suspended trading. Right? They just stopped trading. But that was the entire reason for the system. It was to create a price signal when you're doing too much to stop it. If you're going to not do that part, then you don't actually have a price system. Right? You have the illusion of a pricing system. And there are, for every one of the ones you can say this worked, like lead and gasoline, you can point to the others where it clearly isn't working, like climate, for example. I mean, you're not seeing the emission reductions that people have been wanting to see since the beginning of this discussion. No matter what mechanism is tried, they're not working. And so it's not to say that it can't work in specific circumstances and specific places, but what I like to say about acid rain and climate change is that sulfur dioxide, SO2, sulfur is a dioxide, is a dioxide, and carbon dioxide, CO2, is a dioxide, but they're not the same dioxides, right? They're not the same thing. And you can't say, because this worked with sulfur dioxide, it's going to work with carbon dioxide. No, because they're not the same. And so, I mean, every once in a while, a blind hog will find an acorn, right? So some of these things work, but we don't look at the counterfactual of what didn't work.
You know what's interesting about all of the things that we're talking about? It's this notion that zero should be the target, that there's zero tolerance, that the risk is too high. And I think the term for it in the literature is precautionary principle, that you take the extreme action just out of an abundance of caution. And I wonder if that's what's causing our problems with our models. So you begin by projecting out that it is possible to achieve a certain unrealistic target, but because you've seen, oh, well, this is achievable, my model tells me so, then it gives us false sense of what you can actually do today in order to achieve that outcome. So I'm still trying to figure out how we inject some reality into any of these discussions. So begin though by talking about why it is that zero is such a compelling target, why it is that 100% risk mitigation or 100% safety. I'm not even sure where that notion came from, but as we're talking it through, it seems to me that I'm seeing it more and more and more. One death is too many, and therefore it results in a lot of different public policy choices. How did that come about? Because it wasn't always the case.
Well, that's actually hard to say. Again, this is beyond my pay grade in terms of I'm not a philosopher.
I'm just wondering if when in any of the things that you researched, if you sort of saw the beginnings of where this attitude started seeping in an example.
Yeah, I call it the purity crusade, right? It's not that clean is enough, but it has to be perfectly clean. And that's what happened with air pollution, for example. And I guess with regard to things I've covered and picking where things went sort of off the rails from reality, it would have been around the time of cancer when we started doing research on cancer, where previously we had an assumption that if there was a background level you could be exposed to that was not harmful to you.
It's so funny you should mention that, because I don't know if we're contemporaries. I was born in 1971, and so I'm a Gen Xer.
I got you beat by about 10 years.
There you are.
61.
So I remember having discussions about a background level of radiation that wouldn't cause harm to human health. So that's in my memory. But my goodness, I don't even know if you could have that conversation today. And so, so you're right. Something changed. So tell me what it was when you saw it in cancer research.
Well, what changed is that rather than make the assumption that there is a background level that was safe, some researchers decided that, in fact, that wasn't true for certain things, that they are unsafe at any level. Radiation being one of the most easily demonstrated or easily explained, which is the scientists basically looked at radiation and said, if one of your atoms of DNA is hit by one photon at this wavelength, right, it's going to mutate your DNA and cause a problem, which has a cancer path. And so they had a no threshold model of exposure to things. We called them at the time, they were single hit toxins, right? One hit, one cancer. And that model came to dominate in a lot of almost all of the things we now talk about, which is the presumption that there is no threshold. If you read in the literature, it's like there's no threshold. It's a linear or a steady progression from zero up, and that has led to I believe the fallacy that we can go to zero. I turn to the laws of physics, which is the universe doesn't really allow for absolutes. You don't get zero, you don't get absolute things, but humans nonetheless are inclined to purity. And I mean, you can go all the way back to what is the search for God, except for the search for purity, right? For abstraction. But I think again, modern technologies have taken that adaptive human trait, to go into terms of evolution, and made it somewhat maladaptive. What we're inclined to believe that was adaptive to our ancestors to get our genes to where they are today, it's a maladaptive thing because your senses are easily fooled by the numbers and the graphic images that are enabled by the technologies and by modeling.
We have to talk this through a little bit, and I keep on obviously thinking of pop culture references from my history as I'm thinking through some of the things that may have shaped my thinking on this. And one that comes to mind is Fight Club and Ed Norton's character, which is an actuary, I believe, he does calculations for an auto company about whether they allow a certain flaw in their design to persist, knowing it will kill people, because does the cost of the recall exceed the amount of the payouts that they're going to do for the people that get killed. Therefore, you can take a very cool decision about whether or not you just pay the money out. And I think people are sort of viscerally appalled by that notion that we would say that there's a certain band of harm that might come to somebody by making a decision. But I suppose the consequence of that is that we have an unrealistic expectation of being able to mitigate all risk in the future. There's sort of one thing that comes to mind. The other thing that's so interesting is how we have grandfathered in certain levels of risk that we're able to tolerate based on what the norms were at the time when those risks came in. I mean, boy, if we created swimming pools now, outdoor swimming pools, would we ever even allow them because of the number of kids who have drowning accidents? Or ladders, would we be allowed ladders with the number of people who fall off of them? Or even more so, the automobile, when you think of the carnage that happens with auto accidents, it's strange. And maybe even more to the point, with influenza, we were able to accept a certain level of risk associated with respiratory virus season that seems to be eliminated to zero with the new COVID respiratory virus. And so I'm looking for some return to a more balanced approach in how we analyze data and risk. And the more I'm talking to you, the more I'm feeling like we've passed the point of no return. And so I'm wondering if you can just sort of comment on that, is why it is that we've accepted that there's a certain level of risk, and now for any new risk that comes about, it's almost a zero tolerance. I'm perplexed by that.
Yeah, I don't understand it myself, and as we discussed before we started recording, I haven't got to my COVID chapter yet, and so my thoughts on that are nascent. But it is one of the things as a biologist that has driven me a little crazy, is that from the very beginning, when they said we're going to have a war on a virus, a virus is a thing you don't declare war on a virus. It's like saying we're going to have a war on hurricanes, or we're going to have a war on earthquakes, and we're just not going to have any more earthquakes, and we're not going to have any more hurricanes, and we're going to have zero harm from earthquakes in the future. That's our war. Our war is to end all damages from earthquakes. And if you said that, people would look at you like you were dancing on one foot, right? You were a few taquitos shy of a fiesta platter, as we would say here in Las Vegas, because everybody instinctively knows it's like, no, that's kind of crazy. It's like, we're going to fight a war on gravity. People are getting heavier every year, and we can't have that. So we're going to fight a war on gravity. And so it's the same with, as you said, somehow we accepted that. Nobody said we're going to fight a war on polio. We're going to fight a war on death from polio, but polio itself, to determine you're going to fight a war against a virus, against a thing that exists more or less beyond any human control. Crazy thinking, but we did it, and we do it all the time with zero waste. I just wrote a piece on plastics. So in Canada, for example, plastics, only about 1% of plastics are ever littered. The overwhelming majority goes safely, 90 some odd percent goes safely into a hole in the ground, in the sanitary landfills where it's not going to hurt anything. Another 8 or 9%, I think, is recycled, and maybe 1% gets into the environment in Canada. And I can guarantee from the center of Canada, it's probably not getting to the oceans, right? But Canada is heavily embroiled now in a war on plastics, on single-use plastics, despite the fact that we have experience only from 9 months ago of people who would have refinanced their house to buy hygienic wipes made with plastic, sent to them in plastic bottles, transported on trucks with plastic components and rubber tires, truck tires, which are themselves plastic and which shed plastic to the environment every time they turn on the pavement.
And let me add to that, we wore plastic-based masks on our faces every day. We use plastic syringes in order to be able to inject people with the vaccine.
That's right, plastic swabs, plastic. If you need an IV, if you do wind up in the ICU and you need an IV, plastic bags, plastic tubes, plastic syringes, syringe frames. You're surrounded by plastic in a hospital. Basically, every surface that isn't metal is probably plastic because they're non-porous, right? And so, so even in the face of the fact that plastics are saving lives by the zillions right now, but we have to have zero waste. But why? Why? It's not. It doesn't make any sense at all. To be talking about Canada, especially in Canada, to be talking about a war on plastics in Canada is crazy, especially again when more than 90% of the world's pollution problem that does get to the environment comes from like 9 rivers in Asia, and has nothing to do with Canada at all, which is so. But we focus on these purity things, but there might be a plastic microbead that gets somewhere.
I can make an argument. Let me put this one to you, because we ended up shipping our materials off, presumably for recycling, to China and Malaysia and Philippines. And as it turned out, they weren't being recycled there. And I think maybe that's it. I mean, I recall seeing the image of somebody who tried to track down where one of these bins went to. And sure enough, they saw a Canadian prominent grocery store bag that was in this heaping pile. And so I think, and we've also seen the images of the tortoises or the birds with their stomachs open, and it's full of plastic. And so I think, again, going back to the issue of images being really powerful, one of the things that people viscerally want is, yes, we've got to solve that problem. Politicians have told us this is the way we solve it. Ergo, I'm going to support that move. So I suppose this is the big issue, is when people are inclined to have models and inclined to have a predisposition towards simplistic answers and defined numbers. So 0 is a great number, a great target. How do you bring nuance back into the discussion so that you can implement policy that will actually work toward achieving the objective you're trying to reach? How do you begin a policy discussion when people are entrenched in that particular way of thinking?
Well, it's really hard, and it's an issue that I've discussed with my Fraser colleagues for 20 years now, which is the basic idea that we have operated on in the past is of empiricism, which is you simply point to the data. Mm-hmm. And I think that is the genuine solution to the problem. Is if you should be working on the data and looking at asking the question of, okay, there's what level of plastic pollution is tolerable, just as you'd ask what level of sand pollution is acceptable, right? So we use rock, we break it down into gravel, we break it down into sand, it goes elsewhere. That's not what nature was going to have happen to it, but we assume there's a certain level of that that's acceptable. And we move from that argument to none of this is acceptable. The answer should be, look, let's look at the data. Here's what's happening. Nobody's being hurt. This is the acceptable level of loss because it's the background level. It's going to happen anyway. That's where we should be discussing. Unfortunately, society, I think, has lost its inclination and ability to do that. And I don't know where that came from, whether it's the education systems beginning in the 1960s that started emphasizing relativistic concepts rather than absolute concepts, where we lost, people started losing the understanding that let us reason together based on data. We went to, well, but that's only your interpretation of the data. And I honestly, I don't know how we get back there. And it's one of the frustrations, I think, that anyone who works in the think tank world who is an empiricist must be feeling and should be thinking about, which is, we believe that empirical reasoning together is the way to solve problems. But what if that's not working? How do we walk our own talk? Okay, at what point do we look at it and go, yeah, but people are not listening to this, and how do we influence people? How do we reach them to move the dial away from bad outcomes?
Well, then let me get you to
it's a
give
really tough problem.
So let's see if we can try to do that here, because if the solution is not to slap a label on plastics being toxic, and if the solution is not to identify 6 single-use products that we're going to phase out the use of, I wonder if I can remember them all. It's the cutlery and straws and stir sticks. It's the rings on the top of the 6-pack of beer cans, and a couple of others along those lines. If that is not the solution, what then is the solution? Because this is the difficult part. Do we even agree in what the objective of those laws are meant to be? I mean, the objective of those laws, ostensibly, is to prevent plastic from showing up in the ocean. So if these 6 things, banning them is not the direction to get there, what is the alternative that we should be looking at? What would you propose?
You're not going to ask me any hard questions, huh, Danielle?
You said you just wrote on this. You said that you're a big fan of I guess recycling. Like, if we have this debate over, do we recycle, do we dispose?
So my question is, okay, it's last week, and you have to go to the hospital because you're sick, and they show you to your hospital bed, and they hand you your ceramic mug and your ceramic utensils, and they're going to keep those. You're going to share those. Are you going to share those with the guy in the next bed?
No.
No. Do you want the syringe? Are you going to share the syringe that was used before? You're going to take that?
No.
No. And so literally just yesterday, we knew it's a life and death thing. Don't reuse the thing. It's, well, we're going to wash it. Yeah, but how perfect is your washing? Have you used my dishwasher? I'm not going to rely on it. An autoclave maybe, but we're not autoclaving everything. So yeah, I mean, it's I think the whole fixation on straws and cutlery is like, just ask yourself, right? So somebody just is next to you on the subway, they're eating ice cream, they just sneezed, they offer you a bite of the ice cream on their spoon. You going for that? No, I'm not going for that. Do you want the disposable one that hasn't been touched by any human hand since it was packaged? That's what I want. And I think that's what all humans instinctively what they really want, which is why we have that. It's just that some people have set themselves against that instinctive understanding of, yeah, I'd like to throw it away. I'd like to have it go away. And how you manage that issue, again, I think, step back. I don't like littering. One of the things that has always driven me crazy since I was a kid. My mother was a heavy smoker. She had asthma. I hate cigarettes. Cigarette butts became an iconic thing in my mind with the absolute horror of what was wrong with the world. And it drives me crazy. And seeing when we were kids, and there were a lot of people smoking, remember, you'd see in windy weather, you'd see entire drifts of cigarette butt lakes fetching up against the bottom of stairs outside, right? And it's like, and to me, this was like utter horror. Every time I saw that, it's like I'm seeing thousands of people choking to death in a hospital like my mother. But so I hate litter as much as the next person, possibly even more. But what do you do about it? Do you try to stop the possibility of it happening, or do you try to create a set of incentives that incrementally and along the way will constantly adjust to reduce that probability without banning the thing? So we should be, if our problem is litter, increase the penalties on litter, right? And again, this is a joking concept, but if people were really serious about cigarette butt littering, for example, they say, well, let's just ban filters, right? And ban cigarette filters, which of course is going to lead to massive more people dying. But we won't have litter, but you don't do that. So I'd say with plastics, we have to find ways to tighten the penalties for littering, as opposed to saying, I think this product does not have a place in the future, and this one does.
I think you're right. So litter is at the foundation of why we've made that decision. But then you've got value judgments of how you would like to address the issue of litter. And I think perhaps it's the recycling campaigns. Again, I'm a child of the 70s, so I grew up with reduce, reuse, recycle, and sometimes it's hard for me to take something that's plastic and to throw it in the garbage. But then we also have these problems of, I don't know if I'm taking the plastic and taking it to the recycle bin. Is it really being recycled? And so there also is some sort of coding into us now because of the societal messages that we get that make certain types of options for dealing with litter more palatable than others. Is there a case to be made that we've got lots of landfill space in North America? Maybe we should just be embracing the idea of disposal, or should we be embracing recycling, or should we be trying to find new ways of turning those products into something else? There's a few examples like waste to energy. You take the waste stream and you turn it into energy production, so at least you only have ash at the end of it. Or if you can decompose different waste streams so that they can be turned into biodiesel, then maybe that's a more palatable option. But how do we have that conversation if we're not able to, how do you create the empiricism around that discussion so that it's not just visceral, it's not just emotional?
Right. Well, you're taking me into my next book, which is, I also grew up with recycling, and I collected newspapers when I was a kid. In fact, when I was a kid, we were we were not poor, we were lower middle class. But being a misspent youth, I used to go out, and I was constantly living on my bicycle out in the world. But if I wanted lunch money, I found lunch money by grabbing empty soda bottles and turning them into the deposit, and that would buy me lunch. And that was recycling, right? I gathered newspapers for the school paper drive. They used the paper and got money out of it for school equipment or whatever. It was great. I grew up with it, but of course, at a certain point, it stopped being that kind of purity as well. So I'll give you one example. When I was living in Vancouver, I wondered, it's like, why do all of the buildings look green? What's that green? Why do they have the greenish tinge to so much of the buildings? And I was looking at it, and it turns out there's Vancouver has a mandate for recycled fiberglass. And a lot of it comes from came from green glass, right? So it's got a greenish tinge to it. But when you look at glass recycling, what happened was happening in Vancouver was, to recycle the glass, it was being gathered up, ground up, put on trucks, sent to Alberta, turned into fiberglass, put on more trucks, sent back to Vancouver to be put into the buildings that were environmentally clean, because they were using recycled fiberglass, right? Recycled glass. It's like, well, but if I draw the circle around the border of British Columbia all the way over to Alberta, it doesn't look so clean when you add the driving back and forth and the grinding and the burial of the stuff that doesn't get used in Alberta. Not so clean. And recycling is that way. on a lot of things. I love I come to love plastics, and I recycle them. I cook with a lot of plastics these days, and I look for things to do, fun things to do in the microwave with plastics. So I reuse one of my quote disposable containers. I'll use them like a dozen times, but at the same time, there's a lot of faux recycling that's going on, which is it's just not it is not what it pretends to be. And this is the bigger question in my mind is, do we want to be in a world of recycling to zeroness, right? Ever diminishing use of stuff until we're in this sort of iterative cycle of use less. And that's basically that is the recycling model, which is we're going to keep recycling the same stuff over and over again, even though we're going to get diminishing returns each cycle from the energy we put in to recycle it, as opposed to, do we want a pathway where we use stuff and we keep reusing it until there's no energy or usefulness left to it, and then we put it back in the ground where it came from, essentially, or we allow waste to be waste. My philosophical me says, well, that's how the universe works. Because of entropy, everything is running to zero. And so the logical thing is this linear pathway of we use the thing up, and then when it's thermodynamically or energetically stable, and there's nothing to extract from it anymore, we bury it. We make it safe to bury somehow, and we put it somewhere where it won't hurt anything. As opposed to this idea that we either will recycle everything or we just won't use it. Which now, by the way, the anti-plastics people are no longer accepting recycling as the answer. The plastics movement has moved away from reduce, reuse, recycle, and the recycling option to zero creation. They want no manufacture, no use. I would say that you touched on something that I've been doing some research on, which is this question of incineration. I toured a plant back when I was a grad student in the 1980s. It was a pilot project that it was supposed to be a super high temperature combustor waste to energy plant. And it was in San Diego, and it was really cool from a technology standpoint. It was a really cool thing. They took basically a jet engine from like a 727 and put it in the ground so it would blow massive amounts of high pressure into the waste chamber, so that your pressure was super high and temperature was high. And the thing could then run on nothing but wet banana peels and keep generating energy for power. But it was killed because it would have produced a tiny, tiny, tiny increment more dioxin in the emission stream. But rather than figure out how to just improve that technology, they scrapped the idea and said, no, we can't just incinerate things. But my question that I'm looking at in this book is, why not burn it all? Why not extract that last erg of energy that we can use for our use, and then put the thing which is now inert back with all the other inert stuff in Earth?
I like where you're going with that, because if you can get people to get this notion of reduce, reuse, recycle, return, then that can apply to a number of things. It could apply to nuclear waste. It could apply to landfilling. It could apply to CO2 emissions. It's one of the things that is being talked about with carbon capture, utilization, and storage. But you know what is interesting to me is maybe you've given me a path forward as you've been talking, because part of what needs to be done is that when there is an absurd policy based on models and data that is not empirical, maybe the solution is to line up other options so that people can do the comparison. So I guess the way I'm thinking about this is solar panels, for instance. It is an equal absurdity to the example that you gave about the green fiberglass. It's an equal absurdity that we think solar panels are net zero when the crystalline silicon is made in China, mostly with coal plants.
Child slave labor, yeah.
And child slave labor. Or even if you've talked to anybody who has transported all the equipment and turbines needed to establish a wind farm, that's 1,500 in some cases, depends on the size of it, truckloads using diesel-powered vehicles to get it to the site. So I've often said wind and solar are not going to be net zero until concrete's net zero and steel's net zero and transportation is net zero. And I wonder if that is maybe the solution, is that we need more data to be able to counter sort of the sliver of data that's not giving the full picture. Maybe that's the way that we get to a proper assessment, is that we have to do more of these individual analyses.
It's really tough because, of course, humans are inclined to solutionism, and there's been this pressure from all the people who want zero, who come back and say, well, give me your positive, give me your positive alternative. And for some things, at some point, you do have to say, there is no there. So really the right response to people saying we need zero, the answer is there is no zero in the universe. Prior to the Arabic number system, there wasn't even a concept of zero. So you're not going to, right? The universe doesn't allow for zero. And so you're never going to get there from any physical basis in that we know of. So let's stop talking about the drive to zero, and let's start talking about what we can tolerate, what's acceptable to us now. And at the most, let's look for the limits of what our foresight is. Say, maybe it's 1/10 of the data we have. We'll look conservatively 1/10 forward and extrapolate. If we have 10 data points, we'll look to next year. If we have 100 data points, maybe we'll look 10 years. But I think we need to get back to today and what we can accept and tolerate and manage as we go through trial and error learning, and get away from we're going to predict the future, and if we build it, they will come, and right? Because we have a great history with transit systems. We built them. Nobody came. Right? They didn't come. The whole idea of corporate towns, where you'd have corporate would build entire corporations would build cities, corporate cities. They built them. Nobody liked them. Nobody came. Disney tried to build Epcot Center, which was supposed to be an arcology of the future. If we build it, people will want to live in it. Nobody came. China just demolished a bunch of giant skyscrapers that were supposed to be basically apartment towers and condo towers, because nobody wanted to do it. Nobody wanted to be there, and nobody came. So again, we have to, at a certain point, you have to say, no, if you build it, no, they won't come. There's no guarantee, right? Let's look at what has worked and what's working right now, and can we go a little further?
I like what you're saying. Let me ask you about another concept that now sounds so quaint and old-fashioned, but it's been rattling in my head in the last few minutes as we've been talking about it. It's the idea of Pareto optimality. Like, there's got to be a way to optimize the decision making. And then when you've reached optimal, you can't go further without having unintended consequences or unintended costs. And maybe some people think of it as the 80-20 rule. You'll have to tell me if I'm mixing two things up. But there did used to be this notion that you could get most of the way there on a certain amount of effort, and that last 20%, you have to do the cost benefit analysis because it may not be worth the cost. Is there something that we can return to there as we're using that as a tool to assess the direction for policy?
Well, I'm not going to get into Pareto optimality uniquely because my economist friends at the Institute will probably tell me I don't understand it properly, which is fair game. That's fine. I have studied it.
And I probably don't either, so I was hoping you'd correct me.
Well, it's basically the idea that you've gotten to a place where you've done something that you can either make it better, but you can only make it worse. And so that's your optimal solution point, is you're at the place where you can only make it worse if you go further and get less benefit if you go less far. But
is that an abstract concept, or is there a real way to apply that in the real world?
Oh, I mean, it's an abstract concept because it's not going to be the case for all. This is one of the things that with economists, again, when you do an economic model, the outcome is not going to be the same for every person. So, like an example, you have a revenue neutral carbon tax, right? Is it revenue neutral to the state? That is, and this is the Trudeau version, which is, well, we spend everything we get, therefore it's revenue neutral. Well, but that's all government activity then. Everything is revenue neutral because we don't save it, we spend it, and therefore revenue in, revenue out, it's equal, neutral. Is it revenue neutral for the province compared to the other provinces? Where, right? Is it revenue neutral for you as a householder, the carbon tax, in terms of, do you get back everything you pay in? No, we know it's not, right? In fact, it's designed not to be, because we want to make you change your evil ways of emitting greenhouse gases. So if you're living in an uninsulated house, we want to punish you and make you pay more, even though you happen to probably be poor and less able to do anything about it. But still, that revenue neutral. The concept is a model. It won't be revenue neutral for 99.99% of people.
It goes back to this issue of averages, right? Because I guess I'm
Right.
picturing as you're talking, the individual who lives in an apartment downtown and it may be a high efficiency building and they take public transit, they get
Bicycle.
the same rebate as somebody who lives in a rural area who has to commute in and maybe needs a truck, so they have something reliable and may live in an older house, and so they don't have the same level of energy efficiency. They'd get the same amount. So, but you probably would have very different profiles of who benefits out of that. But this is, I guess, the
Yeah, very much.
problem is that a government is not, when you talk about policy changes, policy makers are not able to create perfect programs individualized to every person's particular circumstance. And so I understand now, it's sort of coming full circle. I understand why models are helpful. I understand why averages are helpful, but I don't know how that then allows us to make better policy decisions in the future, since we've just completely dismantled all of the concepts that policymakers are using to try to create good policy.
Well, and this brings us back to Hayek, right? As everything does at the Fraser Institute practically, everything brings us back to Friedrich Hayek, which is it's the fatal conceit of planners that we can do these things. That is the problem, and it's the acceptance that we want to minimize the sphere of that kind of governance and maximize the sphere of self-governance, of manifestation of preferences through markets, is because we know policymakers can't do this. No matter how well intended they are, and no matter what they think, the limitations of knowledge in the hands of individual planners can never be more than the knowledge of 1 million people freely making choices of what to trade for in value that they give and value that they receive as to whether that's a good thing. And hence, when we talk about minimal government or shrinking government, it's not about the concept of government that's bad. It's the shrinking the sphere at which decisions are made and can be made in a tangible sense of empirical. It's very empirical. If I trade you my AirPods for your earbuds or whatever it is, we both establish a value for this. We know what it is. We have it off. It's a mutually beneficial thing. Very empirical. We can chart that to the nth degree, right? But the government says, I want you to use these versus those for all the millions and millions of people who are going to make the decision. They can never be right? By definition, they can't be right for all of those people. But the people acting by themselves, they can all be right for all of themselves. So you get back to this, it all comes back to Hayek and the fatal conceit of planning, which is we need more acknowledgement that there are limitations, it's limitations of simple capability of government to plan. And therefore we need to rely more on the self-realizing day-to-day functionality of markets and personal individual decision-making, and less on grand plans and schemes.
It's funny that you should say that, because I think if you were to say that to me 10 years ago, I might have said that there's certain types of global actions that wouldn't be taken on their own without impositions of targets and treaties and so on and so forth. But what I'm observing now is sort of interesting with 10 years on and all of the advocacy that's taken place around the issue of reducing greenhouse gas emissions. You're actually seeing that consumers are demanding more of businesses. So businesses are creating new product lines that will address that need, or new strategic partnerships with environmental companies, or carbon capture through landscapes or through trees. Like it seems, I'm wondering if it's just that governments are impatient and that they want to achieve a certain outcome because it's become an issue, but that customers get there eventually and businesses get there eventually. And it's really more a matter of taking the time. That advocacy is perfectly fine. And if you can make the best argument in the marketplace of ideas, then customers and entrepreneurs will respond. But it may well be that we're just beginning to see the marketplace developing, that an idea wins in the marketplace of ideas, you don't actually need the coercive government action, because it's the consumers and the entrepreneurs and the business owners who will find ways to achieve that. And maybe it wasn't happening 10 years ago, which is why government began with draconian policy.
Yeah, but it was. So in fact, again, to date myself, if you look back at the history of air pollution control, people think, when was the start of the environmental movement? 1970s, Earth Day, right? California started dealing with air pollution at the local level in the 1950s through smoke ordinances to reduce visible pollution, visible smoke. And that was a manifestation of public desire. It wasn't really the reason that people's behavior was already changing. People were adopting cleaner technologies, natural gas rather than coal, for example. Why? Just because gas was cleaner. So if you had a choice between coal power for your heat or your motor or whatever, or gas was cleaner. People liked clean. We instinctively know it's healthier for us. And we were moving that way. And if you look at the history of air pollution regulation, the further, so it starts at the local level. People start doing it just because they want it. And they tell their local leader, let's stop this kind of stuff. Punish these people who are doing the bad. And then progress starts happening. By the time the state gets into it, the trend is already set, and the state says, we are now establishing standards here, and this is going to solve the problem. But if you follow the trend, nothing changes because of the standards, continuing the trend of the public desire. And then when in the United States, when the feds came in, the same thing happened. Air pollution levels were coming down, and then the state said, now we're going to establish the standard. And the standard is for it to keep coming down, okay? And it keeps coming down, and the feds then say, yep, here's our standard. But the coming down part was pre-existed the standard setting. It's a lot like people say, politicians, the sun comes up this morning, and they say, I made that happen, right? It's going to happen anyway. So yeah, I mean, I would say 10 years ago when people said, we're going to plan for a global solution, it's a fallacy to think that they're going to get global action. What based on history ever made people think that the globe was going to come together to agree on solving climate change by reducing greenhouse gas emissions? If it couldn't agree on human slavery, if it can't agree on women's rights, if it can't agree on fundamental human rights, what makes people think it's going to get together and say, oh, well, but greenhouse gas emissions, yeah, we're going to all agree on that. To me, that was sort of the essence of crazy. I wasn't.
But if the market gets there, then Hayek wins again. We're going to have to take up this conversation again to see how that issue turns out, and to talk about your chapter when you do write it on COVID, because I'm fascinated to see when you get into that some of the conclusions that you'll draw about modeling. Because I suspect that modeling applied to healthcare, I think it's here to stay, and I wonder what kind of conclusions you'll be able to have for us. But we're going to leave that for another day. The book, A Plague of Models, will hopefully be out in the new year. But thank you so much for giving us a sneak peek at the things that you're discussing.
Oh, my pleasure, Danielle. Anytime. For you, anytime.
You bet. That's Ken Green. He's a senior fellow at the Fraser Institute. We hope you enjoyed today's episode. If you like what you heard, be sure to subscribe on YouTube and wherever you stream your podcasts. And to stream old episodes, learn more about the show, and where to subscribe and submit your questions for future guests, visit fraserforum.org.